Hey, Mr. Allred, and in this video I want to continue solving absolute value inequalities. In the previous video, where we were running low on time, we solved inequalities of the first type here, where the absolute value was less than a number, which created a compound inequality. This video is going to focus make some notes here. This video is going to focus on when the absolute value is greater than a number. And we said what that means is we're going to be further away from the center than whatever A is. And that could be to the left or the right. So that creates two separate inequalities. One where we say x is less than negative A, so that means we're further away on the left than negative A, and x is greater than A, which means we're further away on the right than A. So let's see that in action. So in this particular one, the example is 4 times the absolute value of x minus 8, and that is all plus 3, which is greater than or equal to 27. So the first thing to notice is the absolute value is not by itself. So that's what we want to work toward. So we're going to move the 3 over. And that gives me 4 times the absolute value of x minus 8 greater than or equal to 24. And absolute value is still not by itself, so I'm going to divide both sides by 4. Now I haven't divided anything by a negative. I don't need the 4. Haven't divided anything by a negative, so I don't need to change the inequality around. But that gives me the absolute value of x minus 8, which is greater than or equal to 6, if my math is correct. So this goes back to what we had, an absolute value greater than 6, or greater than a number. So what that says is we're going to set it up as two separate inequalities. One can be, and doesn't matter which order you put these in, but it would be x minus 8, and we'll make that less than or equal to negative 6. So basically what we did was we changed the sign, which changed the direction of the inequality. Okay, so that is one possible set of answers, and the other is going to be where we just drop the bars. So it'll be x minus 8 greater than or equal to 6. Now, you're going to solve these separately, but I like to go ahead and write them both out to begin with so I don't forget that there's 2 of them. Now, the easy part is just to go ahead and solve. So we're going to say plus the x minus 8 less than or equal to negative 6 with the x by itself by adding 8 to both sides. And I get x is less than or equal to 2. And then I'm going to solve the other one. I'm going to solve x minus 8 is greater than or equal to 6, so I'm going to add 8 to both sides again. And when I do that, I'm going to have x is greater than or equal to 14. Now, if you look at these two sets and everything worked out correctly, what you notice is your answers are going to be less than 2 or greater than 14. And we have to say or because there's no number that's less than 2 and greater than 14 at the same time. So let's see what that looks like on a number line, and then we'll see what it looks like in interval notation. So I'm going to put my 0 in, I'm going to put my 2 in the number line, I'm going to put my 14. So the first one says x is less than or equal to 2. So I'm at 2, I want everything less than 2. I also want 2, so that's a bracket. The other one says x is greater than or equal to 14. There's 14, so greater than is an arrow to the right. Greater than or equal to includes the 14 with a bracket. So what it's saying here, if you look at this visually, it means I could pick any number, individual number that I have in the shaded regions, and it should work in the original equation if I plug that value in. Okay. Now, that's a disjoint number line, so there's a gap in the middle, so numbers in the middle would not work. But when we write this out in a interval notation, we're going to look at it and write them separately. So arrow pointing to the left is a negative infinity with a parentheses going up to 2 with a bracket. And on the other side we have 14, which is included, and it goes all the way to the right, so that's a parenthesis, infinity with a parentheses. Now we could put or in here. There's a math symbol that writes that or. It looks similar to a U, so if you're doing a program where you have to put this in, or you're trying to read answers possibly in the back of the book, basically this means the same thing as or. This is an or. It looks like a U because it stands for union, because it puts the two sets together and your answer could come from either set. So that's a new notation, so just kind of be aware of it when you see it and how to use it. It's fine on paper to write it with an or, but if you have a software where you're trying to answer questions and it's very specific, make sure you understand the symbols associated with it. Okay? So our answers could come from either set. Now, another example. This one is negative 7 times the absolute value of 2x plus 4. That's plus 7, all less than 42. Excuse me, negative 42. So we see that negative on the right-hand side, and we kind of almost want to quit, but really what we got to do before we can quit is get the absolute value by itself. So there's something added to the absolute value term, so we're going to subtract 7 from both sides. So that leaves me with negative 7 times the absolute value of 2x plus 4 less than, if I subtract 7, this is a negative 49 on the right hand side. So we got an absolute value less than a negative number, so that's kind of worrisome, but this negative 7 out front we need to get rid of because we don't have the absolute value all by itself. So we'll divide both sides by negative 7, and we're dividing by a negative number. So remember what that means. It means we have the absolute value of 2x plus 4 on the left-hand side, and we will have 7 on the right, but it flips our inequality around. So we divided by a negative on both sides, which caused our inequality to flip. Now we have something that looks like what we were working with, absolute value greater than a number. So that's two separate inequalities. The thing inside the absolute value, which is 2x plus 4, flip it around to less than negative 7. And then the other one be or 2x plus 4 greater than 7. So we create two separate ones. We're going to solve both of those. The first one, 2x plus 4 less than negative 7, we'll subtract 4 from both sides. We get 2x less than negative 11, and we'll divide both sides by 2. So that gives me x less than negative 11 halves. And remember, we've got another part to solve. So on the other inequality, 2x plus 4 greater than 7, we're going to subtract 4 again from both sides. So we'll have 2x greater than 3, and then we'll divide both sides by 2. Just solving methods here. So we end up with x greater than 3 halves. So don't have a lot of room here, but we can make it work. Put this on a number line. We'll have 0 in the center. We'll put negative 11 halves on the left of that, and we'll put 3 halves on the right. We want to be less than negative 11 halves, so to the left of negative 11 halves with the parentheses. Greater than 3 halves, so to the right of 3 halves with the parentheses. So another disjoint number line. Putting that in interval notation, left arrow is parentheses negative infinity up to negative 11 halves parentheses for the less than. And we said we could write or, but we'll use the union symbol. And the right hand side, starts at 3/2, but it was a greater than, so parentheses, and then a right arrow will give me a infinity with a closed parentheses. And these are a little interesting to work with, but take your time and make sure you get the absolute value completely by itself before you start trying to determine whether or not you have a solution or how to break the absolute value apart. That's key.